This episode of the DevEd podcast is produced by Thinkster.io. With the rapid pace of change to front-end and back-end frameworks alike, staying up to date with your skills can be tough, but it doesn't have to be. With our expert-led courses on Thinkster.io, you have instant access to hundreds of courses on topics ranging from Angular, React, and Vue to Python, Rails, Docker, and a whole lot more. You can even customize your learning path to include any combination of front-end and back-end technologies that are relevant to you. Thinkster.io, a better way to learn.
Hello, everybody, and welcome to the DevEd podcast. My name is Joe Eames. I'll be your host for today. And on our panel, we have Luis Hernandez.
Hola.
Jesse Sanders.
Hey, everybody.
Mike Dane.
Hey.
And Sam Jeline.
Hey, hey.
Today, we don't have a special guest. Instead, we're just going to be talking about a specific topic. We're going to be talking about learning testing and test-driven development. So I'm excited for this. I just barely last month learned some testing and some test-driven development. So no, I learned some more testing and test-driven development because there's always more to learn. So I'm excited to talk about testing, test-driven development. Been a long-time fan of that myself. I'm sure we got a lot of that. What we need is like some word bell on here to kind of like argue why testing, at least TDD, sucks. So I don't know if we're going to have much of that.
I'll be an honorary word bell today.
Yeah.
Represent the DHH.
There we go.
Is dead.
Unit testing is dead. Yep. TDD is dead. All right.
Jesse, you're going to need to wear flashier clothes if you're going to be word for the day.
Yeah, you do.
Well, I just need a little bit more time, a little bit more prep. If you just give me a heads up that you need a word bell, I can do this.
We should have got Kent on here. Kent C. Dodds. He has a bunch of testing stuff.
That would have been cool. He's a busy guy. He's got more testing stuff to do. Yeah, we're going to talk about testing today, or you're talk about TDD today. We got a lot of stuff to talk about, so let's just kind of dive right into it. Who wants to give us an overview? Who wants to give us the why is automated testing, unit testing, and test-driven development and automated testing important? Who's up for that?
Jesse, of course.
Jesse, you've got volunteered.
That's called voluntold. and Luis is getting a really bad habit of doing this.
Mm-hmm.
So I will speak to automated testing, not so much the test-driven development. How about that? Luis can do the test-driven development side of it, and I'll do the unit testing side. So automated testing, I believe, is a very important part of software development. I think back to when I started out as a developer. This is on, I think, VB5. So for those that don't know, that's Visual Basic 5, creating Windows form applications. Yeah, it's very fun. And there was no such thing as tests. We didn't have any way to write unit tests or end-to-end tests, nothing. And so what would often happen is we'd go in and we would make a change to fix a bug only to break 2 or 3 more items in the application that we'd, of course, only discover once it got deployed out again to everybody's machines. So it was a much more difficult time in terms of deployments and whatnot. I got introduced to unit testing when I came over to AngularJS. Actually, I had prior experience of that. I guess in C# we had in-unit, but where I really took it on is in Angular. With that, I was able to create unit tests that would go in and test the functionality of my application, function by function. Because of dependency injection, I was able to mock out any sort of back-end services, anything that was impacting my function. And I could, with relative certainty, be able to test out and make sure that logic was sound, that all of my conditional statements I was able to step into each one of those types of conditionals. And so that was great. Since really actually about 2004, we've also had Selenium-based tools, whether it be Selenium WebDriver and Angular's Protractor, and now there's Cypress. But now this allows us to test the front end in a reliable way where we can test out user interactions and make sure that the applications respond in the way that we want. So why is that important? That's important because, one, I can catch any sort of errors before it's released to production and be able to test out in an automated way all my acceptance criteria. So if my story has acceptance criteria, I can take that and code these automated tests and make sure that it passes that acceptance criteria. The alternative is to have somebody take those and repeat those every single time in a regression test anytime that a change has been made. And so obviously that takes a lot more time versus having the automated tests where they can run and we can get instant feedback before we even check our code in. Where this really becomes important is when we go to do any sort of refactor on our code. So in a refactor, we're touching code that may have impacts in lots of different areas within the application. And the challenge there is we're often not even aware of all the different places that this code might be used, this logic might be consumed, and it's really easy to introduce a new bug into our application. So any sort of unit tests or end-to-end tests would help us catch those. And the great thing about it is that it's automated. We can make this part of our CI/CD process. So that's our continuous integration, continuous delivery process, and have those kick off and make sure that all of our tests are passing before we push this out to users. So with that, Lewis, I can see in the chat here, has all sorts of really cool things he wants to talk about, including test-driven development. Go for it, Lewis. It's all you.
Yeah, we got some jargon alert. So Luis is going to do our go through some of the stuff that Jesse's talked about and give some definitions out. All right.
No. I'm calling now that there is some jargon alert.
Right.
And then our listeners want to know what, regressions are. What is a regression? Well, turns out that our software sometimes is working 100%, and then you go and make a change in a part of the software and another part of it breaks. We call that a regression. Like, the whole idea is if you make a change that breaks something that used to work before, we call that a regression. So whenever we set regressions and that unit testing or automated testing in general, it doesn't have to be automated, by the way. There's a difference. Like if you ask me, what is the best way to test software? It would be manually. The thing is that it doesn't scale well, right? Imagine that you have a piece of software that it's going to take you, if it's a small thing, you could probably test it manually. But if you're one of those, pick your, online seller, think of the size of the software base of that company. And imagine every time you make a change, you have to go and verify that you didn't break anything, that there was no regression happening. So manual testing, it's good, but you have to find a way to automate those things so that you can run tests every time you touch your software, basically. So the other one is refactoring. Refactoring means simply you change the way that the code is written without changing the functionality of the code. So that would be refactoring. The other one is, we mentioned Selenium and WebDrivers. Those are just, Selenium is a tool for you to do a type of testing, because it turns out that automated testing has different categories that, Joe Eames and this nice panel is going to go through as we go to today's show. Selenium happens to be one of those tools, and WebDriver is, again, part of that ecosystem for testing UIs. We'll talk about those. We also mentioned unit tests and end-to-end tests. We'll define those. Those are just type of automated tests that we can write. And also mocks. He said mocking at some point. And I think I'm going to leave that so that when we talk about mocks and the importance of mocks and spice and all that, but it's just some of the tools that you have at your disposal when you are writing automated tests. And we'll define that in a minute. And then CI/CD, I wrote that in there as jargon, but it's a process. This is not a tool per se. There are tools that do that for you, but it's more of a process of the way that you build software as a company or as a team. This is when you write your code and that code goes through a particular process that will probably include running all of the automated tests as you do commits to your code, as you save code in your repository where you're saving all of your source code. And CD is continuous deployment or delivery. And it's the process where a developer now doesn't have to wait for someone in another team to deploy the software when they make changes. If you have a nice process that does all of the necessary steps to do that, you can give the developer the ability of write some code, push those code to the code repository on a particular place, and that code gets automatically deployed to production so that the users can use that code. So that's what we mean when we say CD. Now, James, take it away.
Awesome. Should have you working for Webster's. All right. So we've talked about a little bit about unit testing, automated testing, and why it's important. But I think it'd be interesting to go through and talk to each of the panel members and see what your experience is with automated testing of any kind and when and how you learned it. We kind of already heard that from Jesse, but Luis, I don't think we really got that out of you when you were doing your definition. Do you want to start? Then we'll go through like Sam, Mike, and me.
So what am I saying? Experience?
Your experience with testing and how you were exposed. Sort of how I'm really more interested in like how you learned it, when and how you started learning automated testing.
Well, it was here actually. Not really. I learned it back in my country, but it wasn't the C# ecosystem. But the stuff that I do now, which is JavaScript, I learned it here on the AngularJS. I joined a company, and part of the projects, all of the projects require that in order for you to ship code, you had to have automated testing for it. That was part of the process. So I kind of learned it as part of that. We did, in my old company in the Dominican Republic, we did try doing some .NET testing, but it was not part of our process. So some people did it, some people didn't. Formally, it was in my first job here in Utah, where it was a requirement of the company in order for you to ship code. And that kind of forced me into it so that I had to do it. It was just AngularJS testing with Testicular first, and then it was Karma and Jasmine. So that's my first real exposure to testing as part of my job. And I know it's Testicular. It was just, sorry, it was a typo. That was a typo.
Oh, man. Those were good days. Those are beautiful days. Sam, what about you?
Yeah, I'll admit I've had a love-hate relationship with testing like a lot of developers. When I was transitioning from finance into being a, quote, professional developer in like 2013, I had a hard time finding good resources for testing in JavaScript back then. So I actually learned a lot about test-driven development from the Ruby side of things. And then when I got into C# and .NET, I really learned a lot more about testing in there, since it's a statically typed language, meaning there's strong types and compiling and things like that. So I'll admit that on the front end, I have almost never done TDD on a like religious basis, because I just find that it can be a waste of time, especially once TypeScript came along. The safe typing just sort of prevented needing a lot of those unit tests. I've stuck with some TDD for building APIs in C# and things like that, because I actually found that really useful, because I could describe the API in the test and then write the business logic to make it happen. But I have personally become way more of a fan of end-to-end testing on the front end, and just writing a handful of those end-to-end tests to test, to prevent like tickets and things like that, like customer support issues and that kind of thing. Because I feel like strong typing handles most of the use cases for unit tests. So that's my controversial topic, but that's my experience. So I prefer unit testing on the back end and integration testing and things like that. And then mostly end-to-end testing on the front end, unless there's some critical piece of business logic that needs to be unit tested.
Now, you said you haven't really done any religious testing on the front end. Have you done any secular testing on the front end?
Yes, I've done secular testing, meaning when my bosses have said, be sure to have tests for this, I go ahead and write the test to make everybody happy and to boost my code coverage numbers. But I didn't really do it with my whole heart. I did it out of obligation.
That's secular testing. So would you call yourself
testing.
A testing atheist or testing agnostic?
I would say I'm testing agnostic.
Yeah, you're not sure if it's valuable or not. You
exactly.
just going through the motions, just on the off chance that it is.
Exactly.
Wow, it's amazing how far this.
Well, I was a religion major in school, so right. I can nerd out about religious theory and tie it to programming all day long.
Oh, geez. Oh, that's awesome. All right, Mike, how about you?
Yeah, so actually, I think I didn't really learn proper TDD or unit testing until my first job, where they were basically just we're testing everything. Unlike Sam's company, they were super religious about 100% code coverage on all the code bases, unit testing, snapshotting, everything. This is mostly on the front end. So there's a lot of Jest and then Cypress for EDEs and stuff like that. But I was in school for computer programming for 5 years, and we didn't really cover a lot about testing, which I think is kind of a big gap in the education system, because I don't think a lot of people learn about it that way. So I learned in my first job, and just kind of in general, I think the resources for learning test-driven development and testing, I think, are pretty sparse. And I think one of the problems is it's so opinionated, and there are a lot of different views. You have Machus, Classicus, there's these different schools of testing. But I will say one place that I found a really good resource was Robert Martin, Uncle Bob, has a really, really good TDD course on his website. So that was probably where I learned kind of the bulk of the theory and just like how to do test-driven development was from Uncle Bob.
I like Uncle Bob. Listen to a lot of his stuff. For me, myself, around about 02 or 03, I was working in a C# shop and we started doing automated testing. And then about 04 or 05, I bought Kent Beck's book, Test-Driven Development by Example, taught myself to TDD. In like 2010, I kind of decided to leave the back-end world and sort of go front end and got really serious about learning testing in the JavaScript side. And so I've done a lot of different stuff with testing since then. And I'm a big fan myself of TDD and using testing. I would definitely say I'm a religious tester, not a secular tester. All right. Based on our experiences, let's talk about how we learn testing. That's kind of like what we try to focus on in this podcast. So learning testing, what are the best ways for somebody to pick up and start learning various types of, let's just talk about, unit tests. Let's focus on unit tests for now. We'll talk about TDD and we'll talk about like integration / end later on. But learning unit tests, I think that's one of the things that's pretty commonly, it's not too uncommon. You'll end up with a job where unit testing is expected of the developers. And TDD is a lot more rare. And sometimes developers do end-to-end, sometimes they don't. But unit tests, that's a pretty common thing. So let's talk about learning unit testing. What are ways that you've learned unit testing? What are ways you would recommend people learn unit testing? What are places to go to figure out how to learn unit testing, especially if you're on your own, right? You don't have good models to follow.
Well, I've mentioned her before, but Sandy Metz in the Ruby community, she has a few amazing talks on testing. I'll link one called The Magic Tricks of Testing. She's just awesome at explaining like why people don't test and how they can do more testing and things like that. So the Ruby community has sort of always been very heavily into testing. And so even if you don't write Ruby, there's a lot of good resources there. I always find it's hard because people say they want resources in testing. And then when people give conference talks, a lot of times they're not really well attended. So it's hard to learn testing.
Probably the main way that I learned is just by practicing in a code base that already has tests. So kind of learning by example. A lot of times when you are learning unit tests, you kind of have to shift your mentality because it is different than writing code because you're essentially writing it backwards, right? You're writing the test that's going to validate that the code works as opposed to writing the code that's actually going to work. So there is kind of a learned skill there. So, if there's like an open source project that has good tests, that's a good thing to do, come pull down the code, make a change, and then modify the tests. Or obviously if you're working at a company that does testing. But I think learning by example and taking a code base that has a lot of tests and seeing how those things are written is a good way to get into it because there is that mentality shift there.
Yeah, I know this guy named Joe Eames who has a really great workshop on unit testing and just testing in general. Even after being in the space for a long time, I actually learned a lot by sitting in on one of his workshops. Remember that, Joe?
I do remember that.
Yeah. I'd like to kind of dovetail on what Mike said. Either an existing project that already has tests, or even if you just have a project that you don't have tests, but you're like, look, I can start writing some tests. I can start playing with whatever testing framework there is, and then start to look at things like code coverage or, try to figure out like, hey, am I actually hitting all these conditionals and am I hitting all the different aspects of this? And so I think that's a good starting point is just jump in and try to do a little bit of it. And then so for the Jargon Alert that's going to come here for code coverage, it's just a little tool that after your tests run, it shows you what statements within your code have been hit and as well as or both sides of the conditionals being met and any code that's not being touched.
I find for people that are newly exposed to testing, the hardest part is not the how, but the what. What should I be testing? So I'd say start with something simple. I think math is good, like writing a few functions that do basic math operations. There's also, if you go and look for Roy Osherovi, I don't know how to pronounce his name, but look for code katas. And he has a few examples on different languages. But if you want to do JavaScript, which is very accessible these days, I would say look for jest JS, justjs.io, follow the getting started guide, and use that tool in the beginning, because that comes with everything that you need out of the box. So that removes some of the friction of having to configure a couple of different tools in order for you to start testing right away. Follow the getting started guide and go from there. And also, when the answer, if you ask me like, what should I be testing? I would say, go for the low hanging fruit, do what we call the happy path. And that only means, what is it that you assume is going to happen when you call this particular function? So start by testing pure functions that you pass an argument and the result is going to be always based on the arguments that you pass to it. And if you don't know what a pure function is, just do a quick Google on what are the characteristics of a pure function. But it's the simplest function that you can write and that you can test. So start doing that. Start working with simple functions with a tool like Jest, and always go for the happy path. What is it that I assume this code is going to do if it works correctly and given the right arguments? And then you'll go from there. And then you start thinking of, all right, what if someone gives me wrong arguments? And those are going to give you different things that you can start testing. And go simple. Always start simple and go from there.
I can totally second code katas, like testing katas. That's, if you just Google that, that's like super great, because there's just simple functions that, have relatively easy kind of testing solutions. So yeah, code katas, totally second that for sure.
That's a good suggestion. I love the bowling game kata. I've done that one a fair amount of times. It's just complex enough that it really helps you really figure out and learn how to do what you're trying to do. So I think it's going to be fun here to talk about test-driven development. So who's up for a definition of what is TDD?
It's like spaces and tabs. One of those chasms that divide the dev community into two camps. So I am on the camp of I think the benefits of TDD justify doing it. The definition is test-driven development or design, depending on who you ask. Because the idea here is that you write your tests before you write your implementation code. And you get interesting benefits from that. This is why some people call it design, because one of the things that you're doing is you're designing, coming up with the API of the code that you haven't written yet. So you could dream it. You were like, okay, if I was using this, what would be a name that makes sense for this particular class or for this function? So you're designing your implementation code at the same time that you're implementing it. Again, I don't know whether everybody here in the panel like it. I think Sam doesn't. Sam, what do you think? TDD or not TDD?
I can actually jump in here because I think it's another point with TDD where you're talking about it's a process for designing a code base. And I think that's one way to look at it. But I also don't think that TDD necessarily has to be about designing the code. And I'm personally in the camp that it's not. I think you should design the code first. I think TDD can aid in that. And there's certainly techniques for designing an entire system through TDD, but I don't know that I think that's absolutely the only way it goes.
So one of the simplest definitions of test-driven development that we haven't mentioned, just in case there are beloved beginners listening, is the idea of red-green refactor. So you write a test and make it fail, and that's the red, and then you write just enough code to make it pass, which is the green, and then you refactor everything to be, better, or maybe add more cases, flesh out a feature. Like I said earlier, I find it useful on the back end if there's some complicated business logic. I just think with modern build processes, it's just really slow to do that approach. It's easier for me on the front end to write code that I can see in the UI and use, and then write tests around those use cases, especially around possible points of failure or things like that. But I have a harder time anticipating those use cases on the front end without actually seeing it live in the browser and messing around with it. I'm not a huge fan of TDD on the front end, at least.
What about on the back end?
I don't mind it on the back end because you're doing more abstract, you're maybe writing an endpoint that has isolated functions, for example, or that you need to pass it this thing and it needs to ensure that these things happen to that thing. And that to me makes sense to write those tests first. And I mean, that does happen on the front end, but I don't know. It just feels like it really slows me down on the front end.
Yeah, I see the value of TDD. I think, honestly, by the time I learned it, I was too ingrained with the way that I was doing things for me to really adopt it. Since I didn't grow up with it, since it wasn't the way that I learned, it's hard for me to adopt it, but I do see other people use it quite effectively. I see it in terms of when people are doing pair programming, that it can be very effective for, especially when we don't know exactly what we're trying to build and we're trying to work through, like, hey, here's some of the things that our expectations are. And I've seen that be effective with teams and with developers that have come up with that. But gosh, for myself, I kind of resonate with some of the other people where it's like, it can be a lot of additional work and takes a lot of time. And especially if I'm already clear about what it is I'm building, then I want to just get in and code it and then start writing some tests against that and then just validate what it is I'm doing.
Hey folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there, The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
I'm a pretty big fan of TDD myself. I've used it pretty extensively on both back end and the front end. So I would say that I'm definitely a religious believer in TDD. I learned Angular using TDD, actually. I was doing a contract for Pluralsight, and they are a 100% pairing, at least at the time, they were a 100% pairing, 100% TDD shop. And so I learned Angular, the original AngularJS, not It's Just Angular, but the other Angular, using TDD. Yeah, I'm a big fan of TDD and what it brings, and a big fan of the value of designing your code up front. For me, I think there's a really big important thing about the difference between testing after and testing first. And so that's what TDD is. TDD is also oftentimes called test first, right? And the reason being is that you write your test before you write the code. One of the really compelling reasons why I really like TDD is because when I write the test first, what I'm actually writing is I'm writing a consumer of whatever code I'm going to write. So if I'm writing an Angular service, if I'm writing a component, if I'm writing some backend or some translation service that's going to say take calls and send them off to the backend. If I'm writing a backend controller or component or service, whatever that looks like, class, when I write a test first, what I'm actually writing is the consumer of that test. At some point, everything that you write has to be consumed by somebody, has to be called by somebody else. So when I'm writing the test first, I'm thinking about whatever the code is that I need to actually have. I'm thinking at it from the viewpoint of the caller, the piece of code that's actually going to call that code. And when I think about the code from the viewpoint of the caller, I make different decisions as to how I design the methods and the interfaces, how I design what the actual class that I'm talking to does, right? And I think about it from, again, the viewpoint of the caller. That way, when I'm actually writing or hooking up to the code that I have written, right? So say I'm writing this, some class that's going to do some piece of functionality. Later on, when I'm in the component that's going to, or class that's going to make calls to that, the way that it interacts with the class is now optimized according to how a consumer would want to utilize and access that class. And so that's one of the things that I really like about writing my tests first, is it just helps me think about how this class is going to be interacted with, how this component or whatever, how it's actually getting interacted with, rather than when I just write the class or component myself. I more think about, well, here I am, I'm thinking about things from the inside of this class, this component, and therefore I make decisions based on what's most convenient for me as the inside. I want you to call this method this way, but the consumers, they might have different desires. They might want to call different methods in a different way and pass in different parameters. And so for me, thinking about that makes a big difference. And also there's just the natural consequence of, if you write your tests after, sometimes it's harder to get those tests to write. And so you have to kind of bang your class around a little bit to get the tests to really work well. So I'm a big fan of writing tests up front when appropriate. I don't think I would say that I do it 100% of the time, but when appropriate, I'm a big fan of writing tests up front. That's, for me, one of the big powers of test-driven design, is that I get to think about my code from the standpoint of the consumer.
I actually totally agree with everything you said there, Joe. I'm also pretty religious about TDD. I always use it I haven't always been that way, but I'd say in the last year or so, all of my development's basically been TDD. And I do just want to bring up one point specifically with front end, because I agree what Jesse and Sam are saying, where sometimes like writing unit tests on the front end and doing TDD on the front end is just a pain. But I think you can also do TDD with things other than unit tests. So one thing I've always done on the front end is I'll write some like Cypress EDEs, they end up failing, and then basically I just write the front end code to satisfy those tests. And in the process of writing that front end code, I'm doing all of that design. I'm not limited by that TDD process, so I'm able to design and try different things out. But then at the end of the day, I have that overarching E2E or that integration test, whatever it is, that's covering it. So I think sometimes with TDD, people tend to get focused on, okay, it's a unit test. It's this very small kind of iterative process. But especially on the front end, I found it useful where it can be a longer process. It's just one E2E, and then you're doing all of the design and all of the stuff that doesn't necessarily need to be covered in the kind of writing the code phase.
That's pretty cool. Sometimes that sort of process where you're like write the end-to-end test first, a lot of times that's called a BDD process, Behaviour Driven Development or Behaviour Driven Design. I myself don't have a ton of experience with that, but you found a lot of success with that, Mike?
I'm actually not a fan of BDD if it's on like a back-end system. But in the front end, I find it's the only way that it works for me. But actually, yeah, I'm actually kind of opposed to that if it's on a like more of a back end environment.
Anybody have experience with like that same sort of idea, but at least for the back end for the API using something like Postman, right? You write your Postman tests first, and then you write the entire implementation of the whatever HTTP call you're going to make. Anybody have any experience with that?
I just learned about that recently. I had never heard of that before, but I saw Joyce Lynn from Postman give a talk at API World, and she mentioned that. I had never considered using a Postman collection as a way to like design your API and test it first, but that's kind of a cool idea because I heavily rely on Postman when I'm building an API. So it makes sense to me that you would use that first as a way to design at least the request and response.
Yeah, I actually like that aspect where you have that really high level test that's covering it, and then you have more flexibility. The one problem I do have with like BDD is I think it tends to lead to a lot of mocking, especially if you're using it as a way to design your system from the outside in. And I guess we can talk about this more, but like I'm not a big fan of mocking, and I think anything that puts that at the forefront, I'm not a fan of.
Did we already define the difference between TDD and BDD and mocking for folks listening?
Yeah, we need to have somebody do that. Luis, our definitions man.
We need a jargon bell. We need
jargon
like
bell, yeah.
buzzer.
I'll talk about BDD and TDD really quick, then Luis can do mocking. So TDD is basically writing the unit test first and then writing the code. So it's a very micro type of a interaction. You write a test, you write some code. Oftentimes a really good cadence with that is that your test is read and failing for 1 to 2 minutes. That's like a kind of an average, sometimes less, sometimes more, but like an average. Within 1 to 2 minutes, you got your test passing. BDD is sort of like taking that micro circuit or cadence or a system and then making it bigger from a bigger scale. So writing an end-to-end test that's failing and then writing all the code until eventually that end-to-end test passes. In that case, the cadence would be much more like 5, 10, 20, 40 minutes, right? It could be as much as that. Obviously, the shorter the cadence time, the better for a lot of reasons. One, quicker feedback, right? And it causes you to write more fine-grained tests, but it's a much bigger cadence. So inside the BDD, if I write one end-to-end test and then start implementing the code, I might then go down and do a whole bunch of TDD. I might write like 10 unit tests, maybe in a TDD fashion, maybe not. Get those tests to pass. And when that's all done, then the whole BDD, that end-to-end test now starts passing. Not everybody uses unit tests in their BDD process. Some people just prefer the end-to-end tests. They write that. They ultimately write the code till it passes and then write another end-to-end test. So there's some variance there, but like I would say a classic BDD is writing the test first for the end-to-end test, then writing the unit tests first for the units, and then continuing that process on over and over. So that's kind of the basics between BDD and TDD. Anything I missed? Anybody have anything to add in that?
I will just add one thing. With BDD, a lot of times it's like very cyclical. So you'll have those big overarching tests, and then a lot of times people will have like smaller, more TDD unit tests in there as well. But yeah, that's exactly right.
Cool. Luis, want to define mocking for us?
Sometimes you have dependencies in your system, and some of those dependencies is also part of the system that you write, and you have control over that. Probably this is where I totally agree with Mike when I say, if it's your code and you have control over it, I don't see a reason why you have to mock it. So I am totally against mocking your own code. But sometimes you have a dependency on code that you do not control. You don't have the source code for that. And when you have one of those dependencies, let's say that you want to make a call to some service, some remote service, and you need some kind of HTTP library that's going to let you do that. Let's mention Axios is a good example. So you have Axios now, and you're going to be making calls using Axios to a third party. One of the attributes of tests is that they need to be isolated and they need to be predictable. How can you guarantee that the code is good if you cannot predict the output of some code that you're executing, right? So whenever you have something unpredictable on the other end that is part of the stuff that you're testing, again, the example of you making a call to an API, that API may fail because there's a problem with the network connection. That API may be unpredictable because you don't know what you're going to get back from it. So in those cases, that thing is not under your control and you cannot predict the results of it. And this is where mocking comes in. So what you do is you have something that for your test that will be put there in place of that unpredictable dependency so that you can now make that dependency predictable. And because at the end of the day, what you're testing, and let's go back to the example of using Axios to hit an API, what you're testing is how does my code react based on the different responses that I could possibly get from this API. So you have a piece of code and you want to test, okay, what happens? What does my code do if this API fails to give me a response, if it times out? What does my code do if I get, I don't know, the expected result? What does my code do if I get a collection of things instead of an object? I'm getting now an array instead of an object. How does my code behave in those places? So that means that you need to control the stuff that comes back from that API that is somewhere on the internet. So what you do is you mock something like Axios so that you can control and artificially create responses that you can use for your tests so that you can test every possible scenario, but you coming up with a response for something that you originally did not control. And that's what a mock is. And there are different classifications, and depending on the ecosystem that you are, you're going to have different names for them. But basically, essentially, at the end of the day, it's just kind of a fake implementation of something that you have now control over.
That's a good definition. All right, so it's worth addressing specifically, how does testing improve your applications?
Well, I was saying that you always want to test your assumptions, but at the end of the day, automated testing is there to test correctness. Okay, is your code behaving the way that it is expected to behave? And that's the whole idea underneath. Again, if you can somehow have a formula to define what the system behaving correctly looks like, you could definitely automate that. And you can execute your system under test and say, okay, given these parameters, given this input, given that I'm calling this particular function with this parameters or arguments, if it is behaving correctly, this is what I should be getting back. So that's what automated test does. It's going to test correctness in your system. Now, be careful though. That doesn't mean that your system is going to be free of bugs. What it means is that at least for the things that you can test for and the things that you're testing for, you can at least guarantee that that functionality of the system is working correctly. So, and there are going to be things that you do not foresee, and there are going to be things, even though you foresee them, there are such broad use cases that you will see that sometimes you just can't really write tests for everything that your system is going to do or everything that can be thrown at your system. But at the end of the day, at least the stuff that you test for, you pretty much guarantee that it's going to continue to work the way that it was if the test continue to pass.
For me, there's ways that testing helps improve my application. So if I'm testing a really complex business logic, often I'll find dead code, or as I'm starting to test it, I realize, well, this isn't as efficient as I would have hoped. And so I start to refactor potentially that code to make it better, to make it easier to test and easier to execute, like it make it faster. Lots of things come out of unit testing, especially. And so I often see that when developers go back in and write tests, they often find that, oh gosh, this isn't really what I thought I was writing. It's producing a result, an unexpected result. So it makes my application better because I'm not shipping bugs to production that might otherwise not get caught, through this. So to me, those are some really good reasons why it's important to do that type of testing. The other way it improves it, as I said earlier, when we have any sort of refactor and we're starting to make changes, it's really easy for us to break an area that we didn't even realize would be impacted by this change. And so by having these types of tests, whether those be unit tests or end-to-end tests, that we're able to see, hey, something has changed. And the other thing I'd even throw in here is another type of testing we haven't even talked about, but it's one of my favorite subjects to speak on, is visual testing. So actually comparing the rendering of the application to what the baseline is versus what it's currently rendering. And what that allows us to do is see them we make small little tweaks, whether it's to style sheets or to images or to our code, where it could potentially change the layout unintendedly, have an unintended consequence.
I'm a really big fan of the concept of coding or testing being like documentation for your code. I mean, we've all had like some weird bug or some edge case that's caused by some business logic or something. And writing a test around that bug just prevents you from having to fix that bug again in the future. When somebody else comes along and is like, why is this stupid thing here? And they remove it and then it breaks something. So I definitely really like tests being a place that future developers can go and look through and see, oh, there's a reason that this code is in here.
I'll throw one more thing out there. Keeping up to date with dependencies. So a lot of times one strategy for working with external dependencies is like, let's say I'm working with a particular library. I might write my own set of little unit tests against that. And then if I want to upgrade or update a version of that library, I can just run those tests against the new version and see, okay, is this still working the way that I expect it? And then, if you're trying to upgrade, you can just try the new version, test it, see if it's going to work for your application. And if not, then you don't have to go through all the trouble of like trying to integrate that. So that's something that people do sometimes with testing as well.
One thing I would like to point out, and I've heard this called the grand unification theory of testing. There's definitely a very, very high correlation between tested code or testable code and good quality code, right? So the classic things that we see that are good indicators of really, really poor quality code, like 500-line constructors and 1,200-line methods, those tend to be pretty much untestable. So when your code is testable, you tend to see a very high correlation between that testable code and high quality code. So that theory being that as code becomes more testable, the quality also goes up. So I would say that's another, we kind of mentioned that already sort of in the various other aspects that we were talking about, but it's worth mentioning specifically that testable code tends to be more maintainable code as well. So we're getting pretty close. I'd like to kind of wrap up with one last section, unless there's anybody else that wants to chip in anything on that final topic. So I'd like to talk about people's favorite and maybe even like least favorite tools working with testing. So what are the tools you like to work with? What are the tools you don't like to work with and why? What tools you think are cool? Because when it comes to testing, tools are a really, really important part of it. So what libraries and tools do you guys like to use?
I've been getting really into Cypress lately, which is for end-to-end testing. And like I said, I use that a lot for front-end test-driven development. It's cool because it has a really good user interface, and then also you can run it from the command line, so you can run it in like a continuous integration environment. So yeah, Cypress is pretty cool. And there's actually a really good talk by our own Joe Eames and Jesse Sanders on it as well, which people can check out.
Mm-hmm. Hey, there's even a course on Thinkster on it.
Who did that course, Joe?
It's a recording of my workshop.
Sorry, I just got to give you a little plug there. So some of my favorite testing tools, one is Jest.js. I really like Jest. As mentioned earlier, it's a great testing tool. I really like being able to use to compare to Snapshot It spares me a lot of time of having to maintain object literals for what I think the output's going to look like for some sort of return data structure. I also can use that to compare HTML. It just makes it really, really nice. I don't have to maintain some sort of mock where I'm putting this data in there and I can get it back out. And so they've got really nice constructs with fixtures and whatnot that make it easy. Also, second on Cypress. I've been talking about Cypress now for, about a year or so, and really love Cypress. Great tool. Combining that with either some sort of visual testing. So as we're going through and we're writing our end-to-end tests, I think it's really helpful to implement something like Percy.io, or there's a couple other tools out there as well. But what they allow us to do is go ahead and create a snapshot with a workflow that it's assigned to it. And so if the snapshot changes between the baseline and what we're actually getting, then we'll get a notification on that. We can hook that back into, let's say, GitHub using some Git hooks, and tie that back to our PRs and make sure there's a reason why that's changing. So those would be some of my favorites.
Well, Just.js, I second that. And on the back end, if you're doing Node, SuperTest, I like it because it's so simple to set up and it works with any of the other testing frameworks. It's got some assertions out of the box too, but it's really simple. It's just a wrapper around an HTTP client, so it will spin up your server and you could do requests, really simple, and it gives you back a response that you could get access to some of the most important things that you tend to test, like the type of the response, the body. You can have access and test the headers real quick. So SuperTest in combination with Jest, pretty good for both front end and back end if you're doing Node.
Awesome. Has everybody gone but me?
I didn't go, but I was going to say Jest and Cypress like everybody else. So Cypress doesn't do native stuff, right? So there's still some drawbacks with Cypress. Is there still
Chrome only
native? It can't do some of the native APIs, right? It's because it's JavaScript.
Yeah, it's got a fair amount of limitations. So it is one of the drawbacks of Cypress. But man, it is so cool for everything.
Yeah,
everything it does work for. Yeah. So I'll throw in one more tool. For JavaScript, there's a mocking tool called Testable. Usually a lot of times you're using JavaScript, either Jest or Jasmine, the built-in stuff works pretty okay. But when you don't want to do some more complex mocking, Testable is a really cool library. There's Sign-on.js as well. That's also a third-party mocking library that's really complete as well. But Testable has a pretty cool API. I really like what they've done. So I'll throw that one in as well.
One of my favorite communities in programming these days is the Angular community. Every time I go to an Angular conference or meet up with some of my friends who are in the Angular community, I have a great time. And a lot of them have wound up on Adventures in Angular. So if you're doing front-end development, you're looking for a way to keep current on the Angular ecosystem, and you want to have a good time listening to fun people talk about great topics related to Angular, then go check out Adventures in Angular at adventuresinangular.com.
I think we'll wrap up with that. Do we have any final words before we move on to tell a friend section? All right, cool. So one thing you would tell a friend about. Who's first?
I go first. I've been playing around with this app called YouTube Music. It's kind of like YouTube's just their Spotify competition, I guess. But one thing I found I was doing a lot was like downloading songs that are only on YouTube and then putting them on my Spotify. But you can just get them straight from this YouTube Music app. So it's worth checking out. It's not as good as Spotify, which is my preferred music player, but it's pretty good.
All right. Microsoft has this thing called Microsoft Whiteboard, and you could have it on your iPad, let's say on your tablet. I've been playing around with that this last week. It's super simple in a setting like, you could use OneNote to take notes, but in a setting like me that I teach online, I was missing the ability to quickly draw something on the screen. So Microsoft Whiteboard seems to be, so far looks like it might work in that scenario. So give it a check.
My new favorite thing is the tile for your keys, especially when you're on a podcast and you can't find your phone when it's sitting right next to you. It's invaluable. No, actually, it's really cool. Every once in a while, my keys in my pocket just get it just right and will continually sit there and press the button. But actually, what I really want to talk about is something I sent Joe a link on earlier today on Twitter. Star Wars Episode 9 is coming out in just a couple of months. And I found this really cool video that is Star Wars Episode 9 trailer, Rise of Skywalker, with the Easter eggs breakdown. And this guy just walks you through all the little tidbits in the video and the trailer that you probably didn't even notice, and has got me really geeked up for the upcoming, I think it's in Christmas time. So
I'll have you know that there's no way I'm going to watch that video until after I've seen the movie. I've stopped watching all previews. I haven't seen the newest preview. I'll enjoy it in the theater. I don't want to see.
Fine. I'll watch it with Ward Bell. And
that's going to go well.
Yes. We're going to spend time digging through all the Easter eggs of,
Awesome. All right. Who's next?
I'll go. Mine is a series of web comics called Strange Planet by Nathan Pyle. He's a cartoonist in New York. And if you haven't seen these comics, they're amazing. He puts them on both Instagram and Twitter, but his Instagram is way more active. So that's what I'll link to. And he's coming out with a book of these comics at the end of November. And it's basically just aliens doing human things and talking about them. And it's hard to describe, but it's amazing.
That's awesome. Okay. Well, I guess I'm last. All right. I'll bet you thought I was going to pick Star Wars. I'm not. As much as I want to, I'm going to pick something else. I've been watching Sam's course on Gatsby and kind of working through it because it's really cool and it's a great way to learn React. And I'm really interested in Gatsby overall. But I stumbled across this thing called Stackbit. Sam, have you played around with Stackbit?
No.
Okay, so they're technically in beta. It's this service where you choose a starter kit. You choose a server-side rendered framework. So you could choose Gatsby, you could choose Hugo, you could choose, what's the Ruby one? Sam, you know this off the top of your head.
Jackal?
You were telling me about it. Jackal, there we go. Any of those, right? Then you choose your deployment you choose a CMS. So you can use Netlify CMS, you can use Forestry.io, you can use Contentful, whatever. You choose the deployment platform, Netlify, any of those. And then your storage, GitHub, you do use, or alternatives. Are there even alternatives anymore? Bitbucket's closing down, right? So anyway, you just put all those together and it just throws the site up there, puts it on your GitHub for you, and boom, you have everything all hooked up. It's like I walked through the part of Sam's course where you go and you like play around with all the starter frameworks and get to like pick a starter that's already designed out for you. But this is even better because it's not just picking out the starter. It like completely deploys it all the way. You've got everything 100% with the CMS hooked up. It was really awesome because I wanted to kind of check out Forestry.io with the CMS. And my dogs are fighting. If you can hear that in the background. I wanted to check out Forestry.io and I wasn't really sure how to do it. And then I was playing with apps with this Stackbit. And so I used Forestry and like, boom, there was this project already created out and I could play around with it and change settings and go ahead and update immediately for me. It was pretty cool. I highly recommend checking it out. Stackbit.com. If you got to put up a new site and you want to do a server-side static site generator, something, Stackbit is super cool. So.
Wow, that looks cool. It looks like a good way to play around with Hugo. They have Hugo on there, and I've been meaning to look at that.
And do cool things like, you want to compare Contentful with Forestry versus like the Netlify CMS? Boom, just create the same project with all three and go and check them out and play around with them. I was really impressed with it, and it went quick and slick and easy, so I like it. There you go. All right, well, thanks everybody for coming. Thanks everybody for listening, and we will be back with another episode.
Thanks, everyone.
Adios.
Catch you later.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.